Okay, so thanks again for joining our webinar series on Intro to Big Data App Hub, Kafka to Cassandra app template. My name is Francis Fernandez. I'm an engineer at DataTorrent. Joining us on the webinar is Deepak Narkhede. He's a contributor to Apache Apex and a software engineer at DataTorrent. Here are some logistics regarding the webinar. This webcast is being recorded. It will be available after the session has ended to watch again and share with your colleagues who were not able to attend our session today. The presentation is already available on SlideShare. Please submit your questions through the session tab. Throughout the session, you can submit your questions via the questions tab in your console, and we'll be happy to answer them as they come up or at the end of the session. Without further ado, I'll hand it over to Deepak.
Yeah, thanks, Francis. Yeah, so today we'll cover some use case of Kafka to Cassandra, and we'll see how we'll see some demo, live demo of that particular application also. So I'll just go over the agenda what we'll cover today. So we'll just cover what is the DataTorrent vision for in the big data world, and then we'll learn about some what is Apache Apex, a platform provided, and then we'll go over some what is the concept called app templates, and then we'll go to the Kafka to Cassandra app template, and then we'll see some live demo over it. So moving on to data vision. So basically, big data is neither productized or nor operationalized. So basically, when you say you want to build an application or functional logic, so the total cost of ownership that includes is the time to develop an application, then time to launch, and then the maintenance of ongoing operations over it. So basically, DataTorrent provides a product which can be built rapidly, so that the application can be built rapidly with simple interfaces. Then there are some code reusability and debuggability tools provided by DataTorrent, and there are some pre-built apps and located so that you can try out your custom logic and modify them as per your requirement. And then also we provide some support dev. We have rigorous testing cycles and product cycles to launch apps quickly. So basically, in big data applications, as you might have known, that there are a variety of input sources. So let's say you say from the data coming from Kafka, some IoT devices, or some files from social media networkings, and there are variety of sinks kind of input data coming from databases, various databases. You can output or get an input from databases, or you can just ingest messages from Kafka. And also there are some in-memory memory processing also, and some for the unbounded data. So we have also batch support and batch process as a stream. So this is a unified which supports streaming as well as batch support. So there are some stateful operations where you have aggregations and rules and some analytics done on it. So as on the figure, you can see that in browser, web service consuming or pushing logs to Kafka server, and then the Kafka input operator is pulling data from Kafka, and then we are doing some kind of what do you say, enrichment and transformation, like decompressing, parsing it, filtering it according to the application logic, and then we do some kind of aggregation dimension computation, and we, let's say, we all again we try to output it to some other output sink. For example, here it is Kafka stored. So where DataTorrent and RTS fits in and Apache fits in. So as you can see, there are various input sources like we get data from RabbitMQ, Kafka, Solace, Flume, S3 Solace, and various data sources. And then we ingest that data from various input sources, and we leverage them and do some analytics according to the custom logic provided. And we term basically Apex runs on Hadoop and Yarn. It is native to Hadoop Yarn, and we have various others distribution supported. And then we can do some real-time analytics and visualization stuff from the data, and then we can output it to some other sinks as mentioned in the figure. So here is how DataTorrent architecture fits in. So at the very base core level, we have Hadoop Yarn for the scheduler and fault tolerance maintenance, and then we have a platform provided by Apache Apex by DataTorrent, which actually uh, does the fault tolerance and things for the applications. So basically, it is a platform, and then we have an inbuilt library which has various operators in it, so that you don't need to write input operators and output operators. So there are many operators in that library. You can just reuse that operators. Let's say you want to uh, get data from Kafka or write to a database. There are already operators present in library. So we have high-level API support and batch support too. And upon top of that, we have an application template where it is ready to use application. So you just need to change some properties to fit in your functional logic or custom logic. And they are ready to use app templates, so that you can change them according to your what is a requirement. On top of that, we have an UI solution which usually do ingestion. If we show this real-time dashboard, then we have visualization, management, and monitoring tools for it. So as I've already mentioned, so these are some use case pattern where let's say you want to have some synchronization or analytics done, so you can get data from HDFS or some database JDBC kind of operators, and then S3 storage or Kafka, and then you output it to some kind of storage like HDFS or S3. Then let's say if an use case like enriching the data, then you'll try to parse, dedupe, enrich some data, format it, and again store it to some other stuff. If there are some uses like machine merge and transform, we have that operators already there, and also the app templates are ready. If there are some kind of a machine scoring use case, then we have H2O kind of operators, and then you can write it to HDFS. So basically, this is how your app hub will look like. So you can go to DataTorrent site and just go over the app hub. You can just import that thing and try using that app with some properties. So these are some advantages that, as I already mentioned, that you can quickly import, launch the application templates. There, you can easily add your custom logic and add custom operators in between that app template. So which also reduces the time to production drastically, and the cost of operation is in production is reduced, because they are already well tested and have fault tolerant support and inbuilt with the platform. Then we also have an real-time visualization metrics shown, operator level metrics, your application level metrics, throughput, latency, etc. We show in UI. So yeah, so you can just go over the link for an various app templates you want. So yeah, I'll just start with the live demo. Yeah, so basically this is an RTS thing. So this is how your DataTorrent RTS looks like. So as I already mentioned that when you go to an app hub, you'll get listed applications. You can see visualization, and let's say I'll just when you want to upload a package, so you can just get the package. So right now our package is Kafka to Cassandra. So I have already loaded that here. So I'll just launch that. So basically, while launching, it will specify few properties which are divided into two. One is the mandatory properties and one are the optional properties. So mandatory properties are the properties which like external configuration if you want. So I'll just give some. Uh, these are some let's say three configuration required for Kafka to Cassandra. So the application here is let you are ingesting data from Kafka, you are parsing it through a JSON parser, and then you are trying to filter and transform some of the tuples. For example, let's say when a transaction record which consists of an amount and that stuff. So let's say my amount, any amount who has greater than any X value, I'll just try to filter it, and I want to do some kind of a real-time analytics on that particular tuple. So right now we'll go to that app, like it is ingesting data from Kafka. Then it will parse the JSON. It will do some filter condition. I have provided some filter condition. So I'll just show you. So, and these are the Kafka topic name. I have created a webinar demo Kafka topic in Kafka cluster, and I've provided the filter conditions that and anything the tuple has amount greater than 20,000. I want to do some kind of transformation for this particular tuples, only for the tuples which have this kind of condition met. So I have some key space created in the Cassandra, and we have a Pojo, which is a netting a plain Java object, which is passed from Kafka, so that you can have your custom schema written there, and you just have to provide a class name here and the output table name, and this is the initial offset for Kafka. So by default it is latest offset. So you latest means that anything which is only new data will be ingested. Right now I'm keeping at earliest because I have preloaded some data on Kafka, so I'll just keep earliest so that it will start from 0th offset. So you can change the offsets so that as per your requirement. So these are some filter condition, filter JSON transform tuple class I'll be parsing. I'll just add one operator for locality so that so locality means I will force yarn to just schedule the Cassandra operator on this particular node. Okay, so this is what my just properties are. So these are default properties, and these are mandatory properties. You have to provide some mandatory. And just launch the app. Yeah, so you'll get some notification that your app has launched successfully. So as you can see, this is in this dashboard, you can see that application state is accepted and it will go soon running. So now, right now in background, what is going at your app operators are getting deployed in yarn containers. So they will be scheduled. So you can see in right side the event tab. your containers are deployed distributedly. So let's say node 0, node 18, node 23. So they are what do you say, jobs, and you can see that it has started processing, and it has already processed the records what are injected. So within a seconds, it has already processed the record. You can see some stats in total processed and total emit. You can see latencies also. And in this is a logical DAG, what we call it as an application. So you are ingesting data from Kafka, then your JSON parser is parsing that data and giving it to filter operator. Filter operator has some condition. Let's say only amount who has greater than 20,000 will be passed. So that's why you can see that it has emitted 1,000, but it has processed only 90, because filter condition has dropped the 100 or 1,000 records. And then the transform operator will do some basic transformation. You can enrich that or enhance that to have some other transformation also. Here the transformation is that your record will be to an uppercase characters. So the incoming name value will be lowercase, and outgoing value will be uppercase. So it is just for demo, we have given a basic transformation, and then it is going to write it to an Cassandra operator. So as you can see, it has already written that record. So I'll just show you. I'll just show you a physical DAG. So you can see that here, even if your logical plan contains a single operator, your physical plan contains 3 Kafka input operators. So basically, this is because I have created 3 partitions of a topic in Kafka, and our Kafka input operator is written in such a way which actually has a partition strategy. For now, I have kept it 1-to-1. So let's say if you try to increase the Kafka partitions to 4, it will dynamically increase your input Kafka operators. So as you can see, the total is done by 10,000 records are already ingested from Kafka, but it is distributed across multiple partitions. So you can see on in that. So if you try to runtime increase the partition at Kafka level, it will automatically detect that there is a change in Kafka, and you will try to change the partitions in your DAG also. So this unifier is added by platform, so that all the tuples are unified and passed on further. And you can see this is a physical DAG. So I'll just show you the. So I'll just show you what was the input file for now given. So as you can see, so this was JSON output given where it has account number, name, and amount. So and amount, just to be noted that name was in small case character. Now this has all been outputted to the Cassandra operator. So as you can see that previously it was there were no records. And if you see you can get that these records were ingested and transformed, and only those records are here where whose filter conditions were met. So you can see that name was transformed to uppercase characters. So this basically this is where you can very easily implement your application logic, and you don't need to worry about the underlying things. It is all taken care by DataTorrent RTS platform, and you can see that here you can see there are multiple containers, and you can get the logs too of that. You can get the logs of app master. You can get logs of independent operators too. And here you have what you say, a locality also mentioned, that you can specify that your three operators will be in single container, or uh, all two operators would be on a different node. You can specify the affinities, like they want to be in single thread mode also. So there are various affinities also provided, locality for the operators. And this all operators are already present in Mallar library, and you can use them as it is. Yeah, if there are any questions, you can just post it on question tab. Yeah, so the roadmap is that. So I'll just take one question here. So the question is about the partitioning stuff. So basically, there are for specifically Kafka thing. So it is depending on the external entity. Let's say, for example, here is Kafka. So if you create a Kafka with, let's say, two partitions, so by default, the engine will detect that there are two partitions present. So it will try to replicate two operators with respect to Kafka partitions. So if this is for one-to-one mapping partition strategy, if the partition strategy is sent to many-to-one, then you can have map multiple topics to a single operator too. So yeah, you can specify the partition strategy as per your requirement. Yeah, so one more question is, how long does it take to implement? So if you want to implement this app, it is hardly 7 to 8 lines of code. So and they are all operators are built in Mallar and this thing, and everything is taken care by platform. So you just in hardly a day or so you can build your custom logic and it is just hardly 6 to 7 lines of code you have to write. Okay, so regarding this, so I just mentioned this thing, that let's say you want to change any property runtime, or let's say filter condition. Let's say now your logic has changed. You don't need to have application what do you say, killed or shut down. You'll just change the filter property runtime. So let I have changed the filter condition. I'll just save, and it will start the further processing with the another filter. So your properties can be changed runtime, and it won't affect your application. So just so you want so question is that, can you show page number 6? So here is the page number 6.
Code.
Yeah, so one more, that is it possible to see code? So already the resources has the links to the code. So and it is open source, so you can just go over the code and watch. So you can. So this slide will be already shared. So it has resources links in it. So you can get the source code there itself. Yeah, so I'll just to move on before the questions are. So there are some visualization widgets, as I already mentioned. You can see the metrics of, let's say, per line, lines, per file completed, number of errors. You can see an application level aggregated metrics also, at how much percentage of your this is completed. We have schema feature where you can specify the schema at only once in the input operator, and it will be automatically propagated by the platform to the all downstream operators. So you don't need to specify for each operator that this is my schema, and it is almost in with completion. So cloud industry, we all have already deployed DataTorrent is on EMR, and Azure is still in progress. And there are many app templates on the repo, and few of them are upcoming, and they will be available soon on DataTorrent app. If there are more questions, you can just tab post it on question tab. So we'll just wait for 5 minutes to if there are any more questions, we'll try to answer them. Yeah, so the question is this like an ETL pipeline? We have an input and put into target. So yeah, so Kafka is basically an input operator, and target we are putting into Cassandra with some kind of custom logic in between. Like for example, your basic logic is like we transform and do a filtering. You can add any kind of a custom logic in between. Yeah, so thanks for attending this webinar. Uh, if there are any further queries, feel free to mail us, and you can subscribe to users.apache.org, and any questions regarding DataTorrent RTS, you have this DT users Google group also. Okay, thank you.